This is E6B calculator. It's a tool used by aviators, student pilots and the pilots to calculate a number of parameters used in flight and flight planning. This is not a tutorial. This is not supposed to be used for learning how to fly. I'm going to reveal a few tricks that I learned that made my understanding easier than was being written on the manual that comes with the tools. And my brain is a bit differently built. I cannot memorize things. I can memorize things for a short period of time, but for me, I have to understand every single parameter or how the system works, so I can memorize as a whole system, as a concept, not as a number or as a theory or as a formula. And if I look at the manual, they try to describe how to use this calculator and appear very simple, but I think they forget to describe what this plastic window or transparent window, what's this base platform or substrate that has a scale on it, what's the use, how to use, and I'm going to show you some tricks. So here I do some flight planning. Will not enter details because this is not the purpose of the recording. And I have the aviation weather website provided by Nav Canada, so this is valid for Canada area. And I have some sort of a table with some numbers that I recorded earlier when I did a bit of a flight planning. So again, this is not instructional video at all. And what I did here, I decided that I want to plan my trip from Vancouver Island and Port Hardy region, but this is not Port Hardy, it's around Comox. And I'm not going to use this Comox airport ever, but for flight planning purpose, I'm going to use just as an example. And I thought of going far all the way to Pemberton. So that's a long journey. So for that reason, I try to divide the trip into a number of legs because it's easier to keep tabs on the calculations on the numbers, and also the wind at the higher elevation change with the geographical area. So we have different weather stations and measurement stations that provide also the data, and it's easier to focus on certain geographical areas close to that monitoring station that give you some sort of information about the wind status and air temperature and other parameters than going global for the whole trip. Otherwise I would have to kind of consider Vancouver station, but of course the winds are totally different in this area, so that's why they have a number of monitoring stations. And I decided my route, and in order to draw on this type of map, you could use a regular pencil with a eraser at the end. But for a while I started to use this type of pen, which are erasable pens, and they are called Pilot Friction. Friction is probably a technology or or a copyright name or something like that. So it's a erasable pen, has a one tip that produces some heat, so you can erase whatever. You see, that one disappeared, so I can draw it again. And so I choose these legs, not really equal as distance, but I choose some sort of a waypoints where I think I can recognize some landmarks, like ocean inlets or something like that. And will not give you the whole story about the flight planning on this case, but I needed some numbers in order to enter into the calculator. And before I go to that, I'll give you a short story, the reason why you need these mechanical devices in flight. I've been boating on Pitt Lake, on a lake, very cold lake, which is a tidal lake. And I had a bunch of gadgets, an older tablet than this one, GPS, an electronic compass and stuff. And it was getting dark, and I lost power on those gadgets, on those devices that had marine maps. And I had to rely on a visual navigation, but I forgot my way in to the lake. And I ran on a sandbar. So my boat was floating on a sandbar, which was only half-meter deep. And the water was freezing cold, like a spring snowmelt water. And now we had to get out of the boat and push the boat. So finally we made it back to the deeper water, but it was dark and we didn't know how to get back to shore because I lost maps, I lost the GPS function. And luckily I had a portable radio, marine portable radio, so I called the Coast Guard, and Coast Guard had nothing to help us with. So they relayed the message to other people in the other boaters in the area, but nobody responded because everyone went out of the lake. They knew the tides and they knew the time when you get out. So finally we managed to see the buoys, the red and green ones, but it was a bit of a challenge getting out without any map, any navigational aids. And I learned that lesson, and I know that I need to rely on paper maps, anything that doesn't have power, doesn't require power, doesn't have a battery. And I know the importance of learning of this tool, because sometimes the flight planning doesn't really give you the accurate numbers, so you may have to calculate while you're on flight. Okay, so going back to the numbers I need from this map. So I need the track, so the direction I'm going to, and for that I'm using this kind of angle calculator, and I set my center point to one of the legs where the leg begins, this leg right here, and I align this ruler with my line, with my desired track, and I set these arrows towards 0 degree, which is north, and parallel to one of these lines here. So I align this 0 and I read the angle here, and my angle is 92. So my track or course would be 92, which I marked right here. Now I need to know where the air, the wind is pushing me, because I have to deal with weather, with temperature, with winds, pressure and all that stuff. So I'm going to aviation websites, Nav Canada, and I select up winds. And since this area is part of Pacific area, I select Pacific and get the FDs. Okay, and I select a station, which in that case is the nearby one is Port Hardy, Penticton, Port Hardy, British Columbia. So of course I have to select the time of my travel, but let's pick, just for some numbers, pick one line out of here. So if I travel around 5,000 to 6,000 feet altitude, I'm going to have 330 at 27 knots and minus 10 Celsius degrees. So I put those down, 330, that wind blowing into my tail. How do I know it's kind of my tail? Because if I look at 330 is here, but I'm going there, so I'm being pushed this way, right? So I assume that my result, my wind correction angle, should be somewhere like that. So, and I'll have a bit of a tailwind, and let's see what the calculator tells me. Okay, so I have this information, track, the wind, direction, speed, and we need to know the ground speed and wind correction angle. So why we need ground speed? Because we need to know how long it takes to travel this distance, this first leg, then second and third and all that stuff. Why we need that? Because we need to know how much fuel we need to use, how much fuel we need to rely on, if we need to stop somewhere in the middle to choose an alternate and stuff. So that's very important to know the ground speed, because if you, let's say, have headwind, then you're going to slower, so it takes you a long time, so you may run out of fuel before you reach your destination. So you need to calculate all those before you start your journey. And let's start to use this calculator. And it has sort of a help right on the top. And it says for ground speed and through heading. So let's describe this one, see what you look at. So you have a rotating disc here, which is attached to a plastic window, which is being used to write on it. Now, most people use a pencil, but what I noticed with the pencil that it scratches this plastic surface. So after a while, maybe a year, depends how often you use this calculator, you will see scratches over the surface. So this pencil, it's a good tool to use, but I found something else. And if I want to use a pen, it's not going to leave any marks on the surface because it's plastic. And I tried this tool, this erasable pen, also does not leave marks on the surface. Okay, and what it does work for me in these things, the markers, permanent markers. Okay, so you could use that, and now I know some people may make a comment. Or you can use a darker color so you can see your mark. And I use this type of markers in other situations. So let's say on my pre-flight check, so I check stuff, so fuel quantity, and I say here 21 plus 21, 42 gallons. And I know I checked that one, but of course after a while you get used, so you don't have to mark. But when you are at the beginning of your student career or whatever, you may want to write stuff. I done this, I done that, and people say, oh no, don't do that, permanent marker, it's a no thing, no. But you have some isopropylic alcohol, and you take a piece of cloth or toilet paper or something, and isopropyl alcohol comes off very nicely. You see, all that stuff is now on the paper. Well, here, same thing. So if you never knew about it, permanent marker comes off with isopropyl alcohol. Of course other alcohols work, but not, this is one of the most efficient I use all the time. So I rather have a better experience writing with something that has high contrast than being concerned that the marker won't come off. Okay, so back to the problem thing. So for ground speed and through heading, set wind direction under the true index. So what we do, we can memorize the steps. So I said number 1, or if I'm forgetful, I write down somewhere. So for number 1, set wind direction under the true index. So wind direction is 330. So true index is right here, it's an index, true index, 330 is here. So I'm going to set 330 under the true index, yes? So once I completed that step, done. Number 2, mark wind velocity up from center point. So they tell you mark from center point, but mark where, what, how, you have to kind of guess. It seems obvious, but you don't have an idea what wind velocity, how to do this type of stuff. So wind velocity is 27 knots, and my center point is this center point, and this background has a scale. You see those lines as a scale with the divisions, and what they want, just to make a line equivalent with the wind strength, so 27 knots. So if you make the line from here to here, that's fine. If you make it from here to here, that's fine. But since this center point moves at some point, it will slide, we'll see later, you need to use this center point with a line. But you see the numbers behind. How do I know where to move this one? Because you may have it set for different value when you get it out from your purse or from your bag. So now let's pick this number 200 because it's a round number. So I see the center point right on 200, and I will not draw a line, but I will make a mark with the wind strength, which is 27. So I have 10, 20, and 5, 7. So here I could use the pencil, like I said earlier, or I could use the permanent marker. So again, I choose 200 because it's a round number. This is the center hole, center point. So 10, 20, 25, 27. Okay, so that's my 27 knots wind velocity mark. So we completed the step number 2. Step number 3. Set true course under the true index. True course is 92. So let's see. So we need to rotate this disc until it reaches 92. I have to hold the camera in one hand. So 90 is east and 2 degrees about here. Okay, but at the same time this dot moved. Used to be here. So remember when we marked, the dot was here because the 330 was here. So now since I rotated the disc that has this plastic window attached to it, the whole thing rotated. So let's see. See the dot moving? Okay, so it used to be 330 when we first marked it. Then when we go to 92, which is east plus 2 degrees, so 92, the dot moved here. Okay, so that was set true course under true index. So number 3 step done. If I don't write it down, I may forget, or you can memorize it. Now go to number 4. Slide wind velocity mark to true airspeed. So true airspeed, according to the POH, the Pilot Operating Handbook, for that RPM, so we decided we go at, so we look at the aircraft performance and we decided we want to go at 2300 RPM, and the airplane goes around 101 knots on still air. So 101 knots, but I went for 100 knots. So airspeed 100. You can do 101. Okay, and so now we are at number 4. So I'm writing number 4, but it's not complete, so it's not check mark here. So slide wind velocity mark to true airspeed. So wind velocity mark this is the mark. True airspeed. So where is my 100? So my 100 is right here. Now this 100 extends nicely like that, like a semicircle. So now I have to slide this dot all the way on top of 100. So I can go that way, or I can use this little plastic tab here to slide. This model is not that easy to use, not that easy to slide, so I rather use this one, aluminum and aluminum, plastic on aluminum slides better. So see, it's almost on top of 100, almost. Okay, so that wind velocity mark, the one we marked at the previous or one of the previous steps, it goes on 100, which is the speed that we got from the pilot operating handbook, from the performance, aircraft performance at that RPM, at that altitude. So you have to learn on that on a separate lesson. And number 4 is completed. Okay, and now we go to number 5. Let's see what number 5 says. Ground speed reads under the center. So under the center is that little hole. It's see the hole? So I have 10 division here, so 110, 111, 112. So we mark ground speed at 112. I already did this calculation before. So number 5 is complete. Number 5 step is complete. So we got ground speed, which is useful to calculate with the other side of the calculator the fuel consumption and how long it takes for each leg. And number 6, wind correction angle reads between the center line and wind velocity mark. So number 6, wind correction angle. So between center line, this is center line, and wind velocity mark, which is this guy, this dot here. And what's the angle here? It says 10 degrees. From here to here is 10 degrees. Then from here to here is another 10. So that is 2 degree marks. So 12, 14, 16, 18, 20. So we have about 13, which, because it's on the left hand side, we say it's with negative, is minus. So minus, wind correction angle is minus 13 degree. Okay, and that's being used when we calculate the heading. So the heading here, so we know how to set our aircraft nose. Okay, but it's not true, it's not magnetic. Magnetic you have to correct with variation, which in Vancouver area it's 17 degree, but you can look at the isogonic lines in your chart. And so heading is the track, which is 92 minus 13, so would be 82, 80, 81, 79, would be 79. So 79 degree, that's my heading. But we need to use the heading indicator, which is according to our magnetic compass. So we will subtract another 17 degree to put into our heading indicator. So we use that instrument in the cockpit to navigate based on magnetic readings. Okay, and so let's see 79, what it shows me here. 79 is this number here. So I need to point the nose of the airplane something like that in order to compensate the tailwind, the wind from this angle at 27 knots. And my ground speed is going to be 112, which is higher than 100 knots. The aircraft performance shows me. So I'm going faster over the ground. It tells me that that tailwind is pushing me somehow like that. So if I correct it, I go this way, then I keep track, I keep the correct track. So it makes sense, right? If you get some weird numbers, you need to think logically. Is this number making sense? And look what it is headwind, crosswind, whatever it is, and make some sense of it, of those numbers. Don't just take the numbers and think the numbers are accurate and used for your flight planning. So that was about using this side of the calculator. So I'm going to record another video about using this side of the calculator and some calculation that you could use, especially when you were in a cockpit. You want to know your ground speed and stuff like that. So I let you go. I don't know if it's any use for you, but if you are a student pilot and if you have hard time understanding the logics behind the use of this toy, this tool, this explanation might be useful to you, and I wish you good luck with your flying. Take care, bye bye.